All right, we can start. Good evening for us in the US and good morning for those in Indonesia. We are very pleased to having you here in the second event of Warekada series that is organized by PERMIAS Nasional. Welcome everyone. First of all, I would like to thank our distinguished speakers tonight who were able to set some of their busy time to be here tonight with us. Also, thank you for all the PERMIAS team who is organizing this event. So my name is Joshua Gombo. I'm currently a PhD student at the Department of Mechanical Engineering at the University of Washington. And for the next hour or so, we will hear from our speakers about their experience in studying and teaching in the US grad schools, especially in the field of computer science and engineering. So this event tonight is intended to be a discussion forum. So please feel free to ask any questions you have by typing them in the chat box, and we will make sure to answer them later. So before we start, I would like to set some rules and ethics in this discussion. So the first one, please mute yourself and only speak when allowed. And if possible, you can turn on your video to respect the speakers and also have fun and ask a lot of questions. So with that, let's start our event tonight, the second Warekada series, Computer Science, Engineering, and Research, by introducing our amazing speakers. So our first speaker is Professor Haryadi Gunawi. He's an associate professor in the Department of Computer Science at the University of Chicago, where he leads the UK Research Group, or UChicago, System Research on Availability, Reliability, and Efficiency. He received his PhD in computer science from the University of Wisconsin-Madison in 2009. He was a postdoctoral fellow at the University of California, Berkeley from 2010 to 2012. His current research focused on cloud computing reliability and new storage technology. He has won numerous awards, including NSF Career Awards, NSF Computing Innovation Fellowship, Google Faculty Research Award, NetApp Faculty Fellowship, and honorable mention for the 2009 Doctoral Dissertation Award. Welcome, Professor.
Thank you. Thank you for inviting me.
Our second speaker is Richard Mahuze. Richard is currently a Master of Engineering student in the System Engineering program at Cornell University. He is currently working on a federated learning and power IoT project that is funded by the National Science Foundation, or NSF. He's also a co-director of technology at PERMIAS Nasional. And previously, he completed his Bachelor of Science in Electrical Engineering with honors at the Oregon Institute of Technology. Richard is originally from Merauke, Papua, and is also an awardee of the LPDP Beasiswa Indonesia Timur Graduate Study Scholarship. Welcome, Richard.
Thanks for having me.
And last but not least, we have Victor Ongkowijaya. He is currently a PhD student at Princeton University for computer science. His current research is broadly in the field of cybersecurity and privacy, with a focus on informing government tech policy. He was previously at the University of Michigan, where he did research on internet censorship and worked at Nokia's network security division. Welcome, Victor.
Thank you, Yasho.
So thank you everybody for joining us tonight, and it is our pleasure to have you guys here. So without further ado, let's start our discussion from Prof. Gunawi. So Prof, most of us here are probably wondering, how did you get to where you are as a faculty? Can you briefly tell us about yourself and your academic journey to be a professor?
Sure, yeah. Again, thank you for having me. Ricky, thanks for the invitation. Joshua, thanks for moderating. Saya rasa untuk sharing mungkin saya di bahasa Indonesia aja. Nanti kalau research baru English, lebih personal soalnya. Dulu sebenarnya pas SMA, computer science bukan field nomor satu saya. Saya sebenarnya demen architecture. Tapi saya iseng tes ke ITB, tes masuk gitu disuruh gambar. Saya masih ingat gambar ikan di kolam ikan yang lagi bersenang-senang. Nah, saya bingung gimana gambarnya gitu. That time terus orang tua saya juga bilang the future is computer science gitu ya. Jadi dari situ ya mungkin percaya orang tua saja. Lalu jadi saya masuk ke Wisconsin. Saya ambil Computer Science. Jadi sebenarnya saya pas masuk juga saya tidak tahu apa-apa tentang Computer Science. Yang saya tahu saya cuma punya DOS operating system, cuma bisa pakai Microsoft Word 1.0 buat bikin PR pas SMA, sama main Digger, Civilization, atau Sangkok, Three Kingdoms. Basically that's it. Saya nggak ngerti apa itu email, saya nggak ngerti apa itu browsing. Tapi untung CS is not just about emails or browsing. Jadi ya dari pas S1 juga saya berasa saya mungkin ada tendensi bantu teman gitu ketika misalnya mereka kesulitan programming, near the deadlines dan lain-lain, jadi saya bantu help gitu. Jadi saya rasa identitas saya juga ada a little bit di teaching gitu. Lalu saya internship langsung yang bentuk co-op yang 7 bulan. Dari situ saya berasa saya juga bukan orang yang demen development gitu ya, yang kutak-kutik satu hal sampai jadi benar-benar jadi produk. Kayaknya saya bukan di situ. Jadi disitulah pergumulan mungkin identitas, sampai saya yakin saya mau definitely ke grad school dulu, PhD. Waktu itu belum tahu saya mau jadi profesor atau enggak. Saya lulus 2001 ya pas S1, jadi it was really a bad timing. .com boom collapse. It's very hard to get to graduate schools. Ya untungnya diterima juga di Wisconsin, walaupun sebenarnya saya udah di reject dulu, long story, tapi ya funny. Di reject, tapi setelah saya bicara dengan profesor yang saya sudah bekerja sama 2 tahun, dia bilang mungkin ada kesalahan, jadi akhirnya ke accept. Lalu ya udah PhD journey took a while, 7 years, karena juga nungguin istri lulus master dan ada anak pertama pas di akhir-akhir tahun PhD. Tapi di lewat PhD situ juga saya makin yakin saya demen research, saya demen ngajar, dan demen dinamika kehidupan akademia gitu. Walaupun tiap tahun kalau telepon orang tua selalu ditanya kapan lulusnya gitu. Saya bilang ya tahun depan lagi, tahun depan gitu. Nah, jadi mungkin karena dalam hal sekarang gitu pandemi ya, ini sangat dekat banget di hati saya ketika kita bicara ekonomi collapse, karena saya lulus PhD itu tahun di 2009, itu benar-benar ekonomi crash juga. Jadi saya itu nasib sial selalu lulus setiap kali pas either .com collapse atau ekonomi collapse gitu. Jadi tapi ya untung, jadi waktu itu saya tidak dapat langsung faculty position, sempat ada dapat offer dari good industry gitu ya. Tapi saya pikir saya mungkin mau coba postdoc dulu. Lalu lewat postdoc itu saya balik lebih yakin lagi gitu. Walaupun sudah dapat offer dari industri, saya yakin tujuan saya rasa di akademia gitu. Jadi postdoc itu juga 2,5 tahun, time period yang juga heavy, tapi lewat situ juga saya yakin after postdoc, wherever, which university that will accept me, I will go as a professor there. I think applying as a professor, you cannot be picky because there's not that many positions out there. So you should just be grateful wherever you go. So itu I think in a nutshell ya, maksudnya perjalanan saya mungkin mencari identitas dan to the point ya, I'm blessed bisa jadi assistant professor dan recently dapat tenure jadi associate professor in one of the good schools in US. Dan yeah, I'm really happy with my job, although the salary might not be as good as the going to industry.
Yeah, that's quite a story. Actually, many of us maybe having like a dream job as a child, but ended up in different career, I guess, later on.
Yeah.
So it's interesting that it's not only your passion in, let's say, in computer science, but also in teaching juga ya. That kind of lead you to be a faculty. That's amazing. So what about you, Victor? Your story might be different. So could you tell us a little bit about yourself and then your journey to be a PhD student in Princeton?
Yeah, sure. So I was born and raised in Jakarta, and I was very lucky, very grateful that I was able to go to college in the US, where I went to University of Michigan. At first, I initially wanted to major in chemistry or chemical engineering, but in reality, as I came to college, I didn't know anything. I didn't know what to do. My essay and college applications were about me being a jack of all trades, don't have any area which I'm really good at or anything like that. But I took a few computer science classes and I really enjoyed it. Something clicked, and I think I've never been more passionate about it. Sorry, I think the audio got caught off a bit there. Yeah, so I felt really passionate about computer science. So I decided to major in it after like about a year or two of taking classes. And my research journey started when I applied to an undergraduate research program where they match you with a professor or a mentor. And at that point, I didn't know what research is about either. I just thought it sounded cool. Like the word itself sounded cool. So I just tried it out and I found that I enjoyed it. And my mentor was really patient with me, even though I knew nothing. I'm like, I was a sophomore, just started learning programming, and my mentor was willing to teach me a lot of things. And I really liked how you can put to use the things you learned in the classroom. So in class, you learn a lot of theory, a lot of different things, but you never actually get to use it in ways that are meaningful. And I think research is what make me feel that what I'm learning is actually useful. Along the way, I also tried to get into teaching. I'm personally, I've always been kind of a shy person. I'm pretty terrified of public speaking. So I decided to, try to get myself a bit more acclimated to that, and went to teaching, TA'd a few classes. And that's what I did for the last 2 years. I taught like an intro to programming class. So at that point in my senior year, I figured I like teaching, I like research. So I figured I should apply to PhD programs where, professors, they do teach, they research as well. And I was lucky along the way. I had mentors to guide me. They have had no idea what a PhD is about, and they taught me all there is to know about that. So I owe it to a lot of people. And long story short, I spoke with a few professors at Princeton, and there was a good match there. And so that's where I am today.
Incredible story. Thank you for sharing. I think the application aspect of the computer science that got you really interested in pursue further education. So that's interesting. And what about Richard? Can you tell us about yourself and how did you get here as a master's student at Cornell?
Absolutely, yeah. Thanks for having me. I was wondering if I can share my screen a little bit. So.
Yes, I think you can share your screen.
Okay.
Can you try?
Yes.
Okay.
Yeah. So when I was thinking about what can I share during this event, so maybe I can start with this sort of preface about the Dunning-Kruger effect. Maybe some of you have seen this plot here. The x-axis is the expertise, the y-axis the confidence, and it's kind of like the executive summary of my journey in computer science. If we can sort of point where I'm at right now, I can probably say that I'm currently right here, and college was right here, where the confidence was at the peak, and then the expertise was relatively low. And yeah, I think this is the current journey that I'm doing right now. And what's interesting about me is that I'm also a career switcher, because my undergrad was actually in electrical engineering. I was very interested in the renewable energy, sort of the power Internet of Things, and also because of the problems of electricity in Papua, I saw that as a challenge, and I wanted to tackle that. So I ended up majoring in electrical engineering, and during my bachelor's years, I sort of encountered this this topic called machine learning, and that's where I got sort of like hooked with computer science. And after that, I realized that, oh, computer science can also be, used and be applied in electrical engineering with systems like sort of Internet of Things and other applications. And after that, oh, I realized to sort of implement these two disciplines, I can major in the systems engineering program, because a systems engineer basically provides sort of a way for various disciplines to work together, including electrical engineering and computer science. And that's, in a nutshell, why I ended up in systems engineering, and my interest in computer science originated.
Yeah, thank you. So basically, it's the combination of interest, kind of same as like Victor, like you have different interests, and then you decided that system engineering is the way to go. So that's quite a story too. Thank you. So it's really inspiring to basically to hear these different stories and background, from our speaker tonight. It really shows that despite all the different backgrounds, you know, we can do it. Like anybody can do it as well. So I have some follow-up questions. So maybe start with Professor Gunawi. Can you tell us what sort of things that you are researching on currently?
Sure. So my research is in what we call as systems. So if you look at computer science, there are a lot of areas, but mainly it's three pillars: machine learning / theory, systems, machine learning, systems, and theory. And of course, inside systems, there's a lot of areas like databases, operating systems, and so on. I do mostly research in operating systems, and I think one of the pitfalls when people hear operating systems is they think that it's just mainly, Linux, Windows, those things. But really what operating systems is any, software layers that sit between the applications and kind of a future, current and as well as future hardware devices. So when we talk about, the massive systems behind Facebook, behind Amazon, Google, and so on, right? You might wonder why when you make a queries search in Google, literally in 500 millisecond or even 200 millisecond, the results will be available, right? And that's just impressive. It's not just about engineering, but there's a lot of deep science behind that. So that's what I do. I primarily focus on two things. One is the on storage devices. For example, in the old days, we have the big giant disk, magnetic platters, noisy and so on, heavy. And today we have the, solid state drives, mostly in your laptops. If you still have disk in your laptops, I think it's time to buy a new laptop. Or, in the near future, we're gonna have what we call as persistent memory. And basically whenever we have new type of storage devices, the software systems need to evolve, because otherwise, your computer will stay slow, right? So in general, things like that, right? And I think related to recently, like the MacBook laptop also have their own, sorry, I forgot, M1 chips, right? If I'm not wrong, right? So it's kind of tell you that the more the software and hardware are integrated, the faster will the systems be. So that's one. And other than that, I'm also looking into cloud computing and into like reliability. What I mean by that, again, if you think about Google, Facebook, it's just amazing, or YouTube, it's amazing, like how their massive availability, right? In the sense that they don't have a lot of outages, right? So I mean, it's they're always online. So, but what happened at such scale, when your software is millions of lines of code, you have bugs in all over the place. So how do you catch those problems? Because think about let's pick, Uber and Lyft, right? If Uber, crashes, having an outage for just 5 minutes, guess what? Within that 5-minute window, everybody gonna go to Lyft, right? And so, you could imagine just like 1 minute or even 5-minute downtime, how much monetary loss the company will incur, right? So so that's basically like that, right? So again, it's kind of and again, of course, sometimes I go back to Indonesia, right? You go to Gojek, or I even forget the ride sharing for the I forget the name, but you could see that the application still often crashes, right? So I think and I'm quite sure that the systems behind it is still, I think, less advanced than the ones that we have in US. But that's, I think, what's amazing about systems is all about performance reliability, where every millisecond matter, right? Every 1 second downtime matters, right? So that's basically where my research is about. And I think in general, I think for those of you who maybe doing undergrad in computer science and still taking basic computer science, I think you haven't really seen the whole picture, because computer science is growing, and primarily because I think the field is really connected to industry. Even when we do research, I have a lot of like new students saying like, hey, PhD in computer science is like, you need to be an Einstein, right? And I say, not really, because 60% of PhD graduates, they go to industry at the end, right? They don't become like professors like me, right? So only like 30%, and the other 10% maybe create startups, right? So that's why, like, how I think the computer science education is really integrated. And even in the research fields, when we write publications, I'm competing with authors from the industry, right? Like, authors from Google, Facebook, they say, hey, we have a systems, and our systems runs well on, 10,000 machines, great. I don't have 10,000 machines, right? So, I mean, it's great at one side, but at the other, on the other hand, it's also like, there's a lot of fun competition going on, right? So I think that's, again, I think looking back, like how, my mom 20 years ago told me to go to computer science, telling me that, computer science is the future, and it is really the future. And it's just, I think growing crazily these days with machine learning affecting so many different fields.
Right. I think we kind of acknowledge too that this kind of field is always growing, right? So there's always new things to kind of explore, to research in. So that's interesting. Mm-hmm. So what about like Victor? Would you mind to share some of your research?
Yeah, I think I'll share my screen and show a few slides here.
Sure. Yeah.
Okay, can you see my screen here?
Yes.
Yeah, okay. So as I mentioned earlier, I joined this research program as an undergrad, and they paired me up with a professor to do research. Let me move this real quick. Yeah, and I was matched with someone with a PhD who heads the research and development division at an internet service provider that is relatively large. They serve a lot of people in Michigan. And at the time, I was a sophomore. Cybersecurity seemed cool to me. I was like, ooh, like hacking. But reality is today I do nothing close to that, nothing close to what's traditionally seen as hacking, but it's still within the field of security. So the internet service provider is called Merit. And there I worked on projects on defending the users against DDoS attacks, so denial of service attacks. And the work I did there, as I mentioned earlier, is nothing close to hacking. It's a lot more like traffic analysis and trying to visualize what's going on. And it looks a lot like this. It looks very confusing, but at the time I actually found it really cool. There are hundreds of thousands of people using the network at any given time. So analyzing that traffic was pretty interesting. We had to sign an NDA and all that stuff to make sure that it never gets out, right? Because this is private information. As with a lot of research projects in the early stages, it led to a poster presentation. And at the time, I thought it was really interesting because it's similar to what we had in like science fair, like middle school or something. And I was pretty surprised that this is an actual thing that people do later on. And yeah, this is pretty common for early stage research. The next project I worked on was on internet censorship. So this is not on the government side, so I'm not censoring people. This is about measuring censorship, which I'll explain a bit more. So the transition was that since I liked networks, I liked the internet, and I liked security, another professor was looking for a student, and my previous mentor recommended me. And she was a fresh professor. She joined her first semester. And that means she might be a little bit in the inexperienced side, but that actually turned out to be a very good thing because she relied on me, who is just a junior, and I'm still learning a lot of things too. And she relied on me for a lot of things. She gave me responsibilities that I wouldn't have gotten as like an undergrad. And this is one of the projects which I've been working the longest so far, and still to this day. It's called Censored Planet, and it's a platform to measure global censorship. So basically, the issue is when governments censor things, they don't need to tell their citizens. They can censor like activist blogs here and there. They can shut down things here and there, and no one would know. No one would be the wiser. And they won't ever tell you like, okay, this is a list of all the things we're censoring, right? It's not transparent at all. So this project aims to fix that. We use technical methods to figure out what your country censors, and anyone can access this data. So if you live in Indonesia, you can go here, look up Indonesia, and check out what's being censored and how it's being censored. And since we use technical methods, we also provide additional info, such as which protocol is being used and what methods are being used to censor things. Some practical applications, for example, recently Kazakhstan did some pretty shady things to censor a lot of things. And Censored Planet was the first platform, one of the first platforms to find this out. And then we reported on that. As with the case of Russia, which I was part of the study, we studied specifically how Russia conducts their censorship. And as opposing to China, China is pretty well studied, but Russia, no one really knows. So this is why we did that study. And some things with Hong Kong and China as well. And another visualization here, for example, we can see how much countries censor. Obviously, China is up there, and Saudi Arabia, it seems. There's another nice little visualization. And the search platform that I mentioned earlier, you look up the country, you see what's being censored. And we just hope to increase internet freedom that way. And after I graduated from Michigan, I briefly went into the field of software-defined networking. So that's purely on the networking side related to the systems that Professor Haryadi mentioned before. I found it interesting, but it was missing some of the practicality that I wanted with researching cybersecurity, right? Because it had immediate impact. And so I moved on to a different project. Now I'm in the Center for IT Policy. We get mistaken a lot for the IT department, so people call for like internet problems or something, but we're not the IT department. We do research on tech policy. So the department is filled with professors with ties to the government, such as FTC, FCC, the White House, and it's very interdisciplinary. There are a lot of social scientists and law students too. The point is to conduct academic research to inform public policy. So for example, think Europe's GDPR or California CCPA. In a nutshell, it's important to know that laws and policy should be backed by science and backed by academic research. So this is kind of where that research happens. Related work involves things like fairness or bias in machine learning. For example, recommender systems could discriminate against people of color, and we want to do studies about that. And we can also do studies about disinformation on the internet, which is really relevant today. I'm personally working on a project with Mozilla to study how users interact with legal agreements. So for example, those terms of service agreements you see and you ignore, that's what I'm actually like looking at. We want to challenge what courts should what courts should see as legally binding. So if we find that users don't actually engage with these agreements, why should they legally bind you? And the data and the science is important here to convince meaningful policymaking. And yeah, that's where I am today.
That's really interesting, and there's some similarities with the research of Professor Gunawi, in terms of like the cybersecurity field. and whatnot. So thank you for sharing. And Richard, could you share some of your research or maybe some projects that you involved in at Cornell?
Yes, I'd like to share my screen to share the research.
Sure.
All right. So the I'm currently working on this research. It's about energy segregation with federated learning. So let's backtrack a little bit with this key question. So right now, there's a sort of a buzzword, which is AI, and AI enables us to learn with data. But here the question is it possible to learn from data that we cannot see? Essentially, the data we cannot obtain. Traditionally, right now, we do AI machine learning by pulling all the data into one location and then do sort of the computation there. And so to answer this question, we have to sort of change that method to a distributed way, and that's where federated learning comes in. This is just an example of data that's publicly available on the left. So right now, if you want to learn about machine learning, right now, there are always data available on the internet. For example, the MNIST data, the CIFAR-10, the ImageNet data, but the sensitive data on the right, they're not really easy to obtain because they're sensitive, and which is kind of ironic because these are the problems that we want to solve with these kinds of data. But the data that we have right now or publicly available are the data on the left, which are not very sort of important for sort of society. So federated learning, in essence, is kind of change the methodology in a distributed way. As you can see here, we have a server and then some clients in the green color. And what it's doing is that it's only training the models using locally available data in the clients. So the server here, it's not seeing any data from the clients or the nodes. It's only seeing the models, the weights of the models, and then it's doing it's called federated averaging because it's only taking an average of all the models weights from all the clients. So by this method, we can perform training of our machine learning models without actually seeing data. This is just an example of the what's being applied. In this case, Google's applying this federated learning to predict our text sort of behavior. So when we type something on our smartphone, you can see that sometimes there's a prediction of what the next word can be. So this is also an example of federated learning because our personal data is not being uploaded to the cloud. It's only uploading the weights of the models. So this is a neat example of federated learning. But for MG disaggregation, right now, so we're not doing phones like the previous example. for an energy disaggregation, we're doing buildings, and which I'm going to explain in a later slide. So instead of the phones, we're gonna train our models with data from different buildings, and from there we can learn a pattern. So what is energy disaggregation? If we can see on the left here, so let's say we have a house and we want to measure, we want to have data of the real-time data of the all the appliance power in the house. So to do that, traditionally we have to attach smart meters on all of the appliances, and this is actually can be expensive because one smart meter can cost up like $50 per meter, and so it's basically not a viable or scalable solution if you want to make this scalable. So instead of doing that, the non-traditional way is just to put one smart meter per house. And from doing that, we can see on the right here, we can have the same power signature as the one this on the left. So without attaching smart meters on every appliance, we can still have the data by doing by applying machine learning models to do this. So yeah, the motivation also why we want to do this is because real-time data can help consumers to save their energy consumption. For example, this study here shows that with real-time data, people can have up to, for example, this one, 12% of annual percent of energy savings. So real-time data can help people to see their consumption behavior, and then with that can help them to reduce energy. And this also an effort to reduce, you know, the effect of climate change, because energy consumption or buildings and energy consumptions in buildings, they have a large impact in climate change. This is just to illustrate the data set that we're dealing with. The x-axis is the different appliances, and the y-axis is the houses that we have in the data set. So we have a very sort of heterogeneous data, and the one line here is the house or the site meter. So this is measuring the total consumption per house. And so to deal with the sort of the heterogeneous, the non-IID, this non-IID data, we categorize the appliances to four types. So for example, the on and off state, multi-state, and the always on state. So just to deal with the because there are various appliances across all the houses, and to do the federated learning, we have to implement a local model. And what we found that the what's being done is the denoising autoencoder model, which perform better than other models. And in this case, the this metric it's a mean absolute error, and then the red one is the RMSE. So from there, we built a federated learning model with the autoencoder as the local model. And this is just to illustrate the experiment setup. So we perform a design of experiment just to see a pattern in the hyperparameters, different hyperparameter settings. And so yeah, this is an active area of research here at Cornell. So some challenges right now, we're implementing different kinds of federated learning. Right now we're only applying federated averaging, so only taking the average of all the models. There are also other kinds, such as the federated stochastic gradient descent, and also other methods. But right now we're only focusing on one, and the hyperparameter tuning part also, because it's computationally very expensive. We have to have a lot of GPUs to do this, and the other one also the metric, because right now we are only using sort of general metric like the mean absolute error and other metrics. And also the security part, also it's very tricky. It's tricky because federated learning is still early, I think, in its application. So people can hack the model by doing what's called a inference attack. So that can be a challenge as well in the future. So yeah, I think that's the research that I'm doing.
Yeah, thank you, Richard. I think that's an interesting field or areas, because I think we have this a lot of like great machine learning models, to learn something. But the challenge is, how can we get like a really good data? Because sometimes data can be corrupt too, right? So, or maybe can be like really noisy, and that will be a challenge. So thank you. So at this point, I would like to give some time to Prof. Gunawi for a short presentation about the current climate of computer science in Indonesia. And so for Prof. Gunawi, the time is yours.
Okay, thank you. Okay, can people see my screen?
Yes.
Good, okay, all right. Yeah, so this will be just a quick 5 minute. I think this is one of my, passion, vocation in helping Indonesia, even we are 12-hour apart. This is Indonesia in computer science, how we are far behind in producing STEM doctorates. This is based on US statistics data that is published by the National Science Foundation. Okay. Oke, coba. Jadi saya bahasa Indonesia juga. Jadi di sini di tahun 2018 kita bisa lihat bahwa di Amerika Amerika meluluskan 55.000 PhDs in general ya, di semua field. Tapi kita bisa lihat 77% dari PhD yang lulus ini adalah di science and engineering. They are telling us that doing PhD in science and engineering is really valuable. Nah, yang menarik tentu mungkin buat many of us, this is not a strange things, tapi mungkin buat teman-teman di Indonesia banyak yang tidak tahu bahwa, even within that high number, 15,000 international students in science and engineering, among the students, 36% are international students, dan 63% domestics. Okay. Now, I think this is the interesting number. I'm not sure, maybe we should be sad a little bit. Jadi kita lihat, this is number of students that, number of PhD awarded by every country. This is top 40 countries or economies in 2018. Kita bisa lihat from PhD students from China, they have about 6,000 students awarded PhDs in US, from India 2,000, and Indonesia unfortunately only 82. Okay. Okay, and so of course this is not proportional. Of course, we also need to rationalize this with respect to the number of populations, because China and India are definitely much bigger country based on number of population. So I do some calculation. But I think in a nutshell, the conclusion is China is 5 times larger in population, but they're able to produce 75 times more PhDs than Indonesia, and India is 5 times larger, but able to produce 15 times more PhDs than Indonesia. Okay. Now, of course, again, this is information maybe not so much alien to us. Many of us who have been in graduate schools, that pretty much in STEM fields in US, PhD education is $0. That is the standard, meaning that the university will pay your tuitions, and on top of that, they're gonna support you with stipends, right? And this is a statistics that says that different fields in life sciences, physical sciences, mathematics, and engineering, that we could see actually, in computer science and engineering, that 90% of the students are really financially supported, right? Again, there's a lot of money from teaching assistantship as well as research assistantships. Okay. So what is the problem with Indonesia? I think, again, I try to go back home every year and talk to the students. I think the biggest problem is the lack of information, right? I think the most surprising question I got is, Pak, ada beasiswa nggak? Ada beasiswa nggak? Dalam hati saya, ya ada beasiswa di Amerika banyak gitu, bahkan 90% is by default ada beasiswa gitu ya. Tapi yang terjadi di Indonesia adalah di mana myth-nya bahwa untuk bisa sekolah tinggi di United States atau di Eropa, mereka membutuhkan a lot of money via fellowship sebelum mereka even apply ke US. Jadi banyak mereka misalnya berharap dari LPDP atau dari Fulbright atau dari other external fellowships, right? Which is very, very low probability to get. And of course, I think for many of us di US, kita tahu bahwa again the money is a lot inside US, dan it's a very diverse graduate school. Domestic students and students from all of our countries in the world, right? But of course, the big challenge is this big wall, right? The admission process. How can you pass through the admission process? And that they need preparation, right? They need 1 or 2 years of preparation, doing research and so on. But many of them don't have the opportunity to do that. Oke, jadi balik buat computer data science, I think for many of us who are in this field, this is definitely the right field to choose. Kita bisa lihat number of graduating CS students. Kita bisa lihat abis .com boom, kita collapse dikit ya waktu itu ya, karena aplikasinya intinya cuma web doang, .com doang. Tapi sekarang I think it's real because we have machine learning, we have systems that really impacts all other fields, not just impact within the CS field itself. Okay, so yeah, so jadi ini memang vocation saya, dimana melihat gimana at the same time, of course, doing research in US bisa membantu mungkin murid-murid Indonesia yang bercita-cita untuk melanjutkan studi tinggi di Amerika Serikat gitu ya. Jadi saya sejak 6 tahun lalu saya membentuk GIG, like you want to be a geek. Jadi stands for Garuda Ilmu Komputer, di mana saya ya datang ke top schools misalnya ITB, UI, dan lain-lain, UGM, dan ya saya bertemu murid dan saya tanya ada yang tertarik misalnya untuk melanjutkan PhD, dan banyak mereka tidak tertarik karena mereka pikir lulus PhD intinya hanya jadi dosen gitu ya. Tapi saya harus membongkar mitos-mitos yang ada bahwa lulus PhD di computer science itu bukan kayak Einstein gitu, 60% of us go to industry afterward gitu. Jadi ya again ya saya bersyukur setelah 6 tahun banyak setelah saya bimbing, dan juga saya juga mau shout out to many of my students di US. Saya lihat ada beberapa di sini, Martin, Daniel, yang datang yang juga membantu advice mereka. Jadi banyak mereka udah di Amerika, udah di PhD di UChicago, Duke, Purdue, Wisconsin, UIUC, and so on gitu ya. ya hopefully one day ini bisa kita expand terus. Yang di tengah itu adalah profesor di Computer Science yang so far aktif, itu ada saya dan Profesor Derry di Boston University. Ya saya juga hope moga-moga in the future makin banyak ada professors Indonesia di Computer Science. Yeah, that's all. Thank you.
Thank you, Prof, for the presentation and for the insights. I think the statistic really shows that we have a lot of catch up to do, especially in the computer science and engineering field. So I hope that all of us here can take some motivation or to contribute back to the field later on. So we are now in the Q&A session. So I would like to remind the participants, if you have questions, please type them in the chat box. We already have several questions coming from the chat, so I will read the question. So the first question is, are there any difficulties in doing research with industry collaborations as an internal student in the US? So I'll give an opportunity for maybe Professor Gunawi to answer first.
Really depends on your advisors. Again, like me, I have collaborators from Seagate, NetApp, different countries. So there might be issues, I think, maybe with national labs, because they these days, of course, with secrecy and everything, like many of them require permanent resident students or domestic students. But not really. I think it depends on your advisor. I think if you want to do research with industry, you want to find advisors who have good track record, working with industry and co-authoring papers with industry. But there's also pros and cons, right? Sometimes working with industry is actually more like short-term minded, like because they want to have research that is translate to their products quickly. On the other hand, doing more like free academic research that is usually funded by NSF is more like forward-looking, where we could say, project what should the next 5 or 10 years, systems or theory or machine learning looks like.
Right. Anything to add from Victor or Richard?
Yeah, I think Professor Gunawi summarized that really well. Just from my experience as well, and from other people I know in the program, collaboration with industry is usually pretty, it's seen as pretty common. Happens more often than other fields, I would say. I'm currently collaborating with Mozilla for my project. In general, at least for computer science, industry has a lot of incentives to want to collaborate with academics and vice versa.
Right. Richard?
Yeah, just to add, based on my experience, right now we're also working with a company who's providing this data, and I think it's very, as a professor and Victor have said, I think they're very cooperative and it's very straightforward. I think it's because of our advisors. So.
Right. Oh. Thank you for the answers. We have another questions from Junita Sirait. So how do our speakers choose whether to get a PhD or a master's degree? So maybe Richard can answer first.
Sorry, can you repeat the question?
Yeah. So how do you choose whether to get a master's degree or a PhD degree?
Yeah. So this is personally, I think, an interesting question, because I chose a master's degree. So I'm gonna speak based on what I chosen. So I chose the master's degree because I personally don't have the sort of patience, you can say, of doing a PhD, because I'm more of a I like to be practical in this kinds of projects. So I at least that's for me. So I prefer to do the master's degree because I wanted to jump into the industry afterwards.
Yeah, I think it's interesting. I think the passion is one of the key factors in PhD. So what about like Victor, you have anything to add?
Yeah, I think fundamentally the biggest difference between a PhD and a master's is that a PhD is research-based. So a master's usually, you might have some research component, but usually the focus is you take classes, you broaden your expertise. But then in a PhD, that's almost always purely focused on training you to be a researcher, whether that is to be a professor or whether that's to be in industry as a researcher. And I think that's the biggest difference.
Mm-hmm. That's true. Professor Gunawi, you have anything to add?
Yeah, I think, that's a great question. I think as a professor in my 7-8 years in my career, I received tons of questions like that. And I think the fundamental is, make sure you have an informed decision, right? So many times we ask that kind of questions because we don't have enough information. So, as I mentioned, some people think, going PhD means, oh, you need to be a professor, but that's wrong, right? Because I have data here. The data says, 60% go to industries. They go to Facebook, they go to Google, they go to, Intel, AMD, and so on, and they go to the research lab division, not really the development. And if you like research, that's maybe the path that you need to go, although you're going to sacrifice maybe 3-4 more years doing school as opposed to going to work, right? So really, I think, get more information, right? Talk to people, talk to seniors, what do people do after PhDs in your respective field and so on. And from then you're going to get your answers by yourself.
Right, yeah, that's true actually, yeah. Thank you for the suggestion. So another question, this is from Pambayun Safira. So the question is, how do we know which field of computer science we want to go to grad school while we've only taken a few CS classes in that undergrad? So I think this is tying to the Professor Gunawi's stories.
Yeah, so that's really a great question. Sometimes what I tell students is choose areas that you don't hate. Don't choose areas that you like, but choose areas that you don't hate, okay? Why is that? And again, of course, you need to love the sub areas a little bit, right? But I think it's you make trade-offs in life, right? For example, if you want to go to good schools and you say I want to be in machine learning, guess what? You're gonna be competing with thousands and thousands of students from all over the country, right? But if you say, hey, I don't really hate systems or maybe some other field that use machine learning, I don't want to be in the theory, then it's a less competition there. Again, that's kind of an information that you need to get, right? So so that's what I tell students, right? And of course you want to jump in using you want to leverage your experience, meaning that if if you love a field A, but a field X, but somehow your grade in X is not so good, then maybe don't apply to X. Don't use X as an entry point, but use the other subtopic. But once you get into a grad school, you're gonna feel like in top schools there's no lock in the sense that you could shop around for different faculty until you find the right professor you want to work with. You have 1 year to do that. So really, I think that's kind of a strategy you want to make. And then I also tell students that even when you do area X in PhD, after you graduate and you go to industry, well, industry maybe not really want you to do area X, maybe X1, X2, or maybe jump to Y. But that's fine, because I keep telling students PhD is not about the subject, but it's about the journey where you're going to be shaped into a more wholesome researcher, where you're going to be bold enough in the future to jump into a new field because you already have a blueprint how to jump into a new field, right? And that's the whole purpose of PhD.
Right. Yeah, I think the key word here is you have to be passionate about the field that you want to take on. Is there anything to add from Victor?
Yeah, I think it's really hard to know exactly what you want to do, especially when you're talking about different subfields. There are so many within computer science. I think my advice would just be to try things out. Even as I'm already in the PhD program, I switch professors. So, you always try to find what's like best for you. You don't feel like you're locked into something you hate. You can take control of like your life.
That's interesting. Yeah, that's true. Richard, do you have anything to add?
Yes, I would say try to, yeah, because of there are various areas of computer science. You have front end development, machine learning, DevOps. So maybe try start with the tutorials first. Try to learn how to fish. So you know what the saying goes. Learn how to read the docs, documentation about all these different techniques, and then from there maybe try applying it to a real world project, and then from there document the results, and yeah, see if it sort of if it's something that you want to keep building on.
Yeah, that's true. I think the early exploration also needed, to kind of know where your passion is, right? So, yeah. So we have another questions. Let's see. So the question is, how much experience or how much research experience one needs before applying for a PhD? Do you have any suggestion for students who get interested in research in their senior year and don't have as much experience? So maybe Professor Gunawi can answer first.
Yeah, so let me tell you what happened on the other side of the table, right? Because, when during admission process, we received like hundreds and hundreds of applicants. So what do we do? So very simple, we go to the publication section and we see who write the letters. We don't care about your GPA. We don't care about your internship or again, maybe I'm not, I think I'm, it's fair enough that, 80%, 90% of faculty work like that, right? That's our number one, filtering process, which means that if you have publications, if you have good letters from, good professors, then your application will move to the top of the pile. So it means we're going to read your applications first, right? Whether you're going to get in or not, that's a second business, but then at least you are in the top of the pile, right? So I think, I always encourage students that, of course, who wants to go for PhD, you need to do research, starting in the junior year. I even have, students start doing research in sophomore, right? And that's fine because, research takes time. Your class projects only last for 2 weeks, 3 weeks. Research projects last for 2 years. It's a different kind of management skills that you need to have, right? And, I do, which is hard, but I keep telling students, if you really want to go to PhD, sometimes, if you don't have time, you need to sacrifice courses a little bit, right? Because again, if we have 3.5 GPA student with, let's say 1 or 2 publications in really good conferences or journals versus 4.0 students who don't have any publication, we're going to trust the former, right? Because the student already went through the process and is successful, because research is just a completely different beast compared to taking courses, right? It requires long-term focus, a different kind of a time commitment, and so on. But if you are already in the 4th year and you are already late in the process, again, there's no such thing as late. If you really want to go for PhD, you could still, when you work in a company, can you do, additional research outside your main hours, right? So, yeah.
Yeah, interesting. Anything to add from Richard?
I would say yes. Having an experience with research would definitely help, as Professor Gunawi have said. So I think and also having the skill set to actually do the research as well. So I think that'll be helpful. I think that's in my opinion, because I'm currently still a master's student, and I chose the master's track. So and yeah. for the PhD route, I think that would be a more intense experience than the master's.
Right. From Victor, maybe.
Yeah, just to quickly summarize. So the question I think mentioned being a senior student, undergrad. It's definitely later, but it's not too late, I would say. I think at that point, if you're not involved in research at all, I would recommend emailing professors. Of course, you have to look them up first, see what research they do. Email them, and professors are usually open to taking in students who are like committed and dedicated. So for that senior year, I would recommend working hard on one single research project and getting that submitted to like a peer-reviewed publication. And as Professor Gunawi said, that's a very important part. So that's the plan I would recommend, and getting recommendation letters as well, which is why it's important to work closely with the professor and get it published.
Yeah, I think I agree. So we have another question. The question is from Ronald Arifin. So the question was, I sometimes get confused on what to learn, like mobile dev, web dev, machine learning, and so many others as a project to learn. Do you have tips on which to start? Also, is competitive programming helpful? And also, what is the main difference between, I believe this is computer engineering and computer science? So maybe Victor, you can answer first.
Yeah, so as far as picking things, again, I think you can't just know right away without trying it. At least that's what I believe. So you should try things out, even just by little bit by little bit. Try to read academic papers, and of course it won't make sense. It still doesn't make sense to me, like if you just read random papers. So try to at least read the abstract, for example, to get a sense. And I think a question was the difference between computer engineering and computer science. Computer engineering is, I think, traditionally defined as in between electrical engineering and computer science. So you get a mix of hardware and software. Whereas CS, that's a bit more separate than that.
Richard, you have anything to add?
Yeah, so about the competitive programming, I would say that would help to some extent. I would say also try to participate in hackathons. I think that can also help you build some new skill set, because it's gonna throw you out of your comfort zone, and that's always a good environment to be in. And I think that can be a project that you can put on your application, and that can be helpful. Yeah.
Right. Yeah. Yeah. That's actually interesting. Suggestion. Participating in competitions. To get more skills and whatnot. Professor Gunawi, you have anything to add?
I don't really have much anything to add to what have been said. Again, I think go back to that. Ask yourself what you want to do at the end, right? So, if it's going to industry sometimes value, hackathon, that kind of stuff, programming contest. If you want to apply for a PhD, in areas that is not programming language, then usually we don't care much about those, programming contests, because we prefer to see publications. So again, really, but yeah, that's the dilemma of, taking computer science, just exciting field, a lot of sub areas. You want to try all of them, right? But at the end, time is limited. You should try out maybe 2-3 areas that you think you like, and just be bold and dive into one of them.
Right. Yeah, I agree with that. So we have a question like specifically to Prof. Gunawi. So the question was, if you're going to end up in industry, people always question, why do you even do PhD, right? Like, what do you even think about?
Oh yeah, so
doing
that's
PhD?
that's exactly again the misconception, right? I think if we look at, I think computer science and engineering fields are just different, right? I think I have colleagues in math, physics, chemistry, right? I think the concept of PhD there and the PhD in computer science and engineering are different. So yeah, so again, you might wonder, right, why I keep saying this. 60% of CS PhDs go to industry, and that's not because they don't get jobs in academia. No, it's really because the industry really wants to absorb that many number of PhDs. I once Googled like how many PhDs are in the Google's engineering team. if I'm not wrong, I get the answer like 17%. How many PhDs are in Uber or Facebook? I believe the answer is between 8 to 11%, right? And why is that? Because, you know, again, those are massive complex systems that they serve billions and billions of users every day, right? Cannot, you know, cannot be down, it needs to be fast and so on. There's just a lot of science behind it, right? And much more science behind it compared to what you just take in undergrad courses. That's what I say, like you haven't seen really the complete whole pictures, right? And you know what, there's one question about development. Development is only application level, right? But there's again systems level, there's hardware level, and again how to apply machine learning, right? And so on. And if you wonder why machine learning is so popular and prevalent today, that's because we are managed to build, you know, systems that could run machine learning. Again, the NVIDIA people, the architecture people, and so on, right? So there's just a lot of, you know, advanced science, computer science, engineering that requires you to do PhD, because in PhD you're going to learn all the skills, research skills, and you know when you go to those industry, go to the research labs, you're going to be responsible in answering where the company should go in the next 5-10 years, right? You will be that person when you have the PhD. And it's usually hard to answer those questions if you only have a bachelor degree. So that's the reason the demand is just huge out there.
Mm-hmm. Yeah, I think I agree. I think from what I've seen too, with the advancements of like technology, like this type of jobs where it requires you know, highly specialized skill that, you know, have this job is growing. So yeah, sometimes the PhD is required for those kind of jobs. So I agree. All right. So the next question is from Imam Wahyutama. So the question was, coming from HPC field here, I'm not sure what is HPC, but could you please share your thoughts if there's any feature for C or C++ or Fortran? This is the programming language in computer science. So I'll let Victor answer first.
I'm not entirely sure what HPC is, but as far as programming languages go, C and C++ has been around for a while. They will continue to be so. They're pretty important languages. And generally, the field of computer science, we don't think in terms of these programming languages. There's just a lot of them, and you can use like a subset of them. And the language itself isn't really all that important as you get into research and as you get industry. You think more about what kind of problems you need to solve, and then you go to what tools you have, and you don't really consider like, oh, is this language going to last a long while, or is this language it's not that much consideration there, in my opinion.
I think somebody just answered in the chat box. HPC is high performance computing. So do you have anything to add, Richard? Like in terms of the programming language, C, C++, Fortran?
Yeah, so for C and C++, I think it's gonna stay around for a long time. Python is built on top of C. So, and also, high performance computing. I think there's also Julia. I think it's emerging. So I think when in doubt, I think it's better to pick the one that's more established to apply them to your project. And yeah, I think that's as far as programming languages.
True. Sorry. Professor Gunawi, you have anything to add?
Yeah, so people in high performance computing, they are basically giving services to a lot of scientists, physicists, chemists who wrote program back in 30 years ago with Fortran and those low-level language. I think Victor said it right, that remember that language is just the vehicle towards the end goal, right? And I don't really understand the term computer science, why it's called science, until I really do PhD, right? You get a major in computer science, not computer programming. Programming is just a means towards the end, right? So So really, I think it doesn't matter. You know, if you're good with C, that's great. That's the lowest level language, and it means that when you study new language, you're going to be very, very fast, right? There will be always new languages in every 3-5 years being invented. But again, it's all about I think skills, troubleshooting skills, logic skills, and so on. That really will bring you far along this road.
Right. Yeah, I think that's true. So there's one question, maybe this is specifically to Victor. So how do you find your research interest as an undergraduate? What's your day-to-day activities as a computer science PhD student? This is from Gabriela.
So I think the first question is, how did I find my research interests as an undergrad?
Mm-hmm.
How I found it? Well, I think there have been questions on this nature before, and I mentioned that I personally can never know without actually doing it. At a point, I was just stuck thinking of, oh, which field should I pick? I really don't know. All of these sounds cool. But I think it all comes down to just, as Professor Gunawi said, you have to pick something and go with it. And if it doesn't work, you move on and you go about it that way. I don't think it's possible to just know right away that, oh, this is what I want 100%. Of course, that might happen. And I think if that does happen to you, that's very good. But I think it doesn't happen normally. So that's what happened in my undergrad years. I just, I thought, wow, security, hacking, I guess kind of cool. I'll try it out. And I kind of tried, and again, I kind of liked it and went forward with it. Day-to-day life as a PhD student, it's comprised of mainly 3 responsibilities. So the first is, since I'm a second year now, I still have to take a few classes. PhDs usually last 5 to 6 years. A lot of PhD students still do take classes. I think PhD students just like to do that in general. So the first responsibility is that you take classes, not as many as you used to in undergrad. So in undergrad, you might take 4 or 5 classes, but in your PhD, you might take 1 or 2 per semester. And then your second responsibility is usually teaching. So you help professors run the classes. The professors usually give the lecture, and then they lead a team of graduate students who help run the class. So develop assignments, grade them, and then teach maybe smaller discussion sections, and so on and so forth. And then the third responsibility, of course, is your research. This is more like a job where you have your boss, which is your professor. So you become part of like this company. You have your coworkers, which are other graduate students working for the same professor. And you have the same end goal. You have to publish, you have to do the research, your professor sets deadlines for you. And that's also like probably the biggest responsibility out of the 3, because the goal of the PhD, you have to publish to graduate.
Yeah, thank you for the answer. So there's one question specifically to Prof. Gunawi. How do you manage your time to work on various projects in parallel?
That's true. As a professor, one of the skill you have to have is context switches. 1 hour I'm doing this, another hour I have to switch to other things. Sometimes I tell my students not to bother me for 1 week because I have to focus on a certain thing. I think research management, like proper documentation, try to not procrastinate a lot, I think is really important. I don't have a quick 1 minute answer for that, but it's challenging. But I always tell students, right? There's no such thing as a permanent weakness, right? When it comes to skills, right? It's just about whether you want to really spend more time improving certain set of skills or not, right? So yeah, it does take time, and I also tell students, it's in the details, right? Why a painting is so beautiful, why a painting costs millions of dollars, because there's a lot of details behind that painting. You just see it 4 or 5 seconds, but it goes through months or years in the making. And same thing, I think becoming a successful in general, I feel it's all in the details, right? Time management skill, documenting things properly, right? And so on. People management as well. Yeah, so sorry, I don't have a quick 1 minute answer, but I think it's every single detail you could say, I could improve this detail then, but of course, don't be too perfectionist in the sense that you want to improve all the details. No, you just want to improve the details that will help your career.
Mm-hmm. Yeah, that's true. So there's one last question. This is for everybody. So for those of us who are interested to study or currently studying computer science and engineering in graduate level, do you have any motivational words or like suggestions or tips to pursue this path? If you can just summarize everything that we discussed. So maybe I'll start with Richard.
Sure, yeah. I think the most important step is to just to get your feet wet first. Sort of the analogy, I think, try to implement some of the techniques yourself. Try to follow along some of the tutorials online just to have a feel of the different frameworks depending on your projects. If you want to do mobile development and other kinds of applications, machine learning, yeah, learn how to just to know the terminologies and things, and then from there try to like I mentioned earlier, implement that techniques to a particular area that you're interested in, and gather the results, document the data, put it in a website or portfolio, because if it's not documented, it's not done. So it's always better. It's always good to document and build from there. Yeah, I think that's my response on that. Yeah.
Mm-hmm. Basically, the early exploration, to the field. Victor, you have any motivational words?
Yeah, I think my first point would be to try to enjoy it. I think with a PhD and research in general, you get really deep into something, and it's really important that you are passionate about it, you enjoy it, and you like it. And if you don't, maybe that's not quite for you. But related to that, the second point is to be kind of perseverant. There are a lot of setbacks. There are a lot of rejections. Like when you try to publish papers, in the peer reviewing process, it might get rejected. For example, you might not get into certain fellowships. There are things like that along the way that's discouraging. So try to keep that away from your enjoyment of the actual thing, and try to power through those other less pleasant parts.
Mm-hmm. That's true. Professor Gunawi?
Yeah, so again, I've shown the graph in my slides, right? I think being in computer science area, definitely not a mistake. I think we should all be, or computer science and engineering, we should all be proud, with our major. I think this time the growth is real in the sense, as I mentioned, that the field is really impacting all the other fields. Biomedical, again, physicists, chemists, and so on, businesses with, machine learning prediction, and so on. And again, yeah, don't get lost. You need to pick one that you like, and at the same time, always get information. And I think, in computer science, this is an open era, right? Where, I think Victor mentioned, like, you should read publications. It's an open publications. The computer science community is just a unique community that we go to all those publication vendors, ACM, IEEE, and say, hey, do not, put our publications behind a paywall. That all of this information, open source, open publications, is all in the internet, right? So it's just a matter of, those who could, I think, peruse and absorb those information is the one that will be, I think, more successful, right? So, just keep in mind. I think the information is out there, and just keep persistent. Sometimes things, get stressful, especially, the pandemic, the economy crash. But I think with respect to computer science, I think we will bounce back definitely. I think the demand is out there. It's just a little bit hiccup at this point.
All right. Unfortunately, we are out of time. So thank you so much for all speakers. To Prof. Gunawi, thank you, Victor and Richard. Thank you as well. I really appreciate your time. And it was really a great discussion. And I'm sure that all of us here can at least get something valuable out of it, that can be added to our future academic career development. So thank you again. So that ends our discussion tonight for the second Warekada series, Computer Science, Engineering, and Research. I want to thank all the participants for joining us and also the PERMIAS team for organizing this event. But before we go, we have like a featured events from PERMIAS Nasional. So the event is the Outlook Economy and Business 2021. So be alert and look out for this event, register. I'm sure it's a great event as well, like this one. Also, we have, we're planning to do another Warekada series in mid-January, and that will be, the topic is life science. So be sure to look out for those events as well. And follow our social media, PERMIAS Nasional, in Instagram and LinkedIn. And yeah, have a great day, everyone, and see you in the next Warekada series by PERMIAS Nasional. Thank you.
Thank you, Joshua. Thank you, Ricky.
Thank you for the organizers. Thanks for having us here.
Yeah.